Welcome back to Science Exposed, where we take the latest scientific discoveries and make them surprisingly relatable.
Think of us as your shortcut to those aha moments minus all the information overload, you know?
And of course, Science Exposed wouldn't be possible without the brilliant mind of Dr. Cameron Jones, who curates all these fascinating topics for us.
Today we're diving into a paper that asks a question I never thought I'd hear. Can AI help us unlock the secrets of bio-inspired materials?
Okay, I'm intrigued, but also a little confused. What do AI and bioinspired materials even have to do with each other?
Well, think about it. Bio-inspired materials research is exploding right now, but keeping up with all those papers is like trying to drink from a fire hose.
Yeah, I can imagine I get overwhelmed just trying to keep up with my Twitter feed.
Exactly. So these researchers thought, what if we could use AI to map out this entire field to see the big picture and find those hidden connections we might be missing?
So they're using AI to create a roadmap for bio-inspired materials research.
Yeah.
It's pretty clever.
It is. They started with over 1,000 research papers on bio-inspired materials and fed them into an AI model that built something called a knowledge graph.
Knowledge graph, that sounds a bit intimidating. Is it like a super-powered mind map?
That's a great way to think about it. Each point on the graph represents a key concept from the papers, and the lines connecting those points show how the ideas relate to each other. It's like a visual representation of the whole field.
So instead of just reading through mountains of papers, researchers can look at this graph and see the connections.
Exactly. And here's where it gets really interesting. This knowledge graph, like many real-world networks, turned out to be scale-free.
Scale-free? What does that even mean?
Think about a social network like Instagram. You have a few influencers with millions of followers, and then most people have far fewer connections. That's a scale-free network. A few key hubs connect to everything else.
Okay, I get that.
Yeah.
But how does that apply to bio-inspired materials?
Well, in this knowledge graph, a few central concepts like biomimicry or self-assembly are connected to a huge number of other ideas. This means that understanding these hub concepts could unlock a deeper understanding of the entire field.
So I'm a researcher trying to develop a new bio-inspired material focusing on these hub concepts could give me a big advantage.
Exactly. It's like finding the most strategic points in a network to maximize your impact.
That makes a lot of sense. But you said this graph could also help us find hidden connections. Could you give me an example?
One finding that really caught my eye was a connection between a flower and nacre-inspired cement.
Wait, a flower and cement? Those seem like they're from completely different planets.
Right. But by tracing the paths in the knowledge graph, the researchers were able to see how these two seemingly unrelated concepts might actually be linked. Remember, nacre is that incredibly strong iridescent material found in things like seashells.
Yeah, I've always been fascinated by how strong seashells are.
Well, it turns out that the way certain flowers distribute stress, the way their petals are structured, could inspire the design of stronger, more durable cement.
Wow, that's amazing. So the AI is helping us see connections that would have been almost impossible to find otherwise.
Precisely. And it goes beyond just finding connections. The researchers actually use the graph to prompt different AI models to generate new research hypotheses.
So the AI is basically coming up with its own research ideas.
In a way, yes. They used models like XLORA, bio-inspired LLM, Mixtral, and even GPT-4 and fed them specific paths from the knowledge graph. The AI then used that information to suggest potential research avenues or even predict the properties of new materials.
That's pretty mind-blowing. Can you give me an example of one of these AI-generated hypotheses?
One that I found particularly interesting involved the design of new sustainable food materials using synthetic proteins. It was inspired by the properties of spider silk and muscle adhesives. Imagine food with the strength and flexibility of spider silk, yet biodegradable and sustainable.
Edible spider silk.
Okay.
That's a little out there, but I can see the potential.
It's about taking inspiration from nature's incredible designs and using AI to translate those principles into something entirely new.
I'm starting to see how powerful this approach could be.
Yeah.
But you mentioned something earlier called isomorphism, and I have to admit, I have no idea what that means.
Yes. This is where things get even more mind-bending. Isomorphism means finding similar structures in different knowledge graphs, even if they have absolutely no shared concepts.
Wait, so two completely different maps can have the same underlying structure?
That's the idea.
Yeah.
And the researchers found a stunning example of this. They discovered a structural similarity between the knowledge graph on biomaterials and another one built from an analysis of Beethoven's Ninth Symphony.
Beethoven, the composer.
The very same. Somehow the relationships between concepts in those two wildly different domains, biomaterials and a musical masterpiece, had a similar underlying structure.
Hold on, I need to wrap my head around this. It's like saying the blueprint for a bridge is the same as the recipe for a cake.
It is a bit like that, and this finding has profound implications. It suggests that there might be common principles underlying seemingly unrelated areas of knowledge.
So there's a hidden order to the universe even across fields that seem completely different.
That's one way to look at it. And this opens up a whole new world of possibilities for using AI to understand the nature of knowledge itself.
This is incredible, and I need to know more. But before we get too far ahead of ourselves, let's explore how researchers are combining this knowledge graph with AI that can actually see and the mind-blowing possibilities that emerge when they do. Stay with us.
Welcome back to Science Exposed, where we're exploring how AI could revolutionize the way we understand and design bio-inspired materials.
I'm still trying to process that whole Beethoven biomaterials connection. But you mentioned that researchers took this even further by using AI that can actually see. How is that even possible?
Well, traditional AI models mostly work with text, but now we have AI like GPT-4V that can analyze images and even videos.
So they can literally look at data, not just read it. That's fascinating.
Exactly. In this research, they used GPT-4V to analyze a visual representation of the biomaterials knowledge graph itself. Imagine showing the AI a picture of that giant interconnected map we talked about earlier.
So instead of just feeding the AI raw data from the papers, they're showing it the connections between concepts visually.
Precisely. And what's remarkable is that GPT-4V was able to pick up on patterns and connections in the graph structure just by seeing it. These visual insights then led the AI to suggest new research directions that the researchers hadn't even considered.
So even the way the graph is laid out visually can provide insights. It's like the shape of the map itself holds information.
That's a great way to put it. It's not just about the individual points and connections, but also about the overall patterns and clusters that emerge visually. This is where the power of combining AI with human intuition really shines.
Okay, that makes sense. But it gets even wilder, right? You said they also combine this visual AI with an actual painting.
Yes. Prepare to have your mind blown again. They took Kandinsky's Composition 7, a famous abstract painting full of swirling colors and dynamic shapes, and showed it to GPT-4V along with the biomaterials knowledge graph.
Hold on. They showed an AI a piece of art and a scientific map. What were they trying to achieve with that?
They wanted to see if the AI could integrate these two wildly different sources of inspiration to design something entirely new.
And did it work?
You bet it did. After seeing both the painting and the graph, GPT-4V designed a new material, a mycelium-based composite inspired by the artwork's shapes and colors.
Mycelium, as in the stuff mushrooms are made of.
The very same mycelium has incredible potential as a sustainable building material. It's strong, lightweight, and biodegradable.
So the AI took inspiration from a painting and a scientific map to design a mushroom-based building material. That's incredible.
Not only that, but the AI went a step further and generated a picture of the proposed microstructure, showing how the different components of the material should be arranged at a microscopic level.
So we're not just talking about a theoretical concept, but an actual blueprint for a potentially revolutionary new material.
Exactly. It's a stunning example of how AI can integrate different modes of thinking, artistic inspiration, scientific knowledge, and visual analysis to create something entirely novel.
This is all so fascinating, but where does this research leave us? What does it all mean for the future of bio-inspired materials and science in general?
It points towards a future where AI plays an even more integral role in scientific discovery and design. We're no longer limited to analyzing data in traditional ways. We can now use AI to find hidden connections, generate hypotheses, and even draw inspiration from sources we might never have considered before, like art or music.
It's almost like the AI is becoming a collaborator in the research process, not just a tool.
That's a great way to put it. And this raises some really profound questions. What happens when machines start suggesting research directions? How do we navigate the ethical considerations of AI-driven discovery? Is this the future of science?
Those are questions that we'll need to grapple with as AI becomes more sophisticated. It's both exciting and a little daunting to think about the possibilities.
Absolutely. But one thing is clear, AI has the potential to completely transform the way we do science. And we're just beginning to scratch the surface of what's possible. Now, before we dive into those big questions, let's take a moment to reflect on the key takeaways from this incredible research and what it means for the future of bio-inspired materials. Stay with us.
Welcome back to Science Exposed, where we've been on this wild ride exploring the world of AI-powered research in bio-inspired materials.
Yeah, it's been quite a journey from flowers inspiring cement to AI designing materials based on famous artwork.
My head is still spinning from all these incredible connections. So before we wrap up, let's try to distill what we've learned. What are the key takeaways here?
Well, I think one of the most important takeaways is the sheer power of combining AI with knowledge graphs. We can now analyze vast amounts of research data and find hidden connections that would be practically impossible for humans to spot on their own.
It's like having a research assistant that can read and connect ideas across thousands of papers at like lightning speed.
Exactly. And it's not just about finding those connections, but also about using them to generate new hypotheses, design novel materials, and even challenge our basic assumptions about how knowledge is organized.
You know that part about isomorphism, finding similar structures in completely different knowledge domains, is still blowing my mind. It's like saying there's a secret code underlying all knowledge.
It is a truly mind-boggling concept, isn't it? It suggests that there might be universal principles governing the organization of knowledge regardless of the specific field, a hidden order to the universe, if you will.
It makes you wonder what other unexpected connections are out there just waiting to be discovered. Do you think this approach could be applied beyond bio-inspired materials to other fields of research?
Absolutely. I think this is just the tip of the iceberg. Imagine using AI to connect research in medicine, climate science engineering, even the humanities. The possibilities are endless.
It's exciting to think about all the potential breakthroughs waiting to be unlocked, but it's also a bit daunting. What are the implications of AI playing such a significant role in shaping the future of scientific discovery?
That's a question we need to consider carefully. As AI becomes more sophisticated, we need to ensure that it's used responsibly and ethically. Human researchers will still play a vital role in guiding the direction of research, asking the right questions, and interpreting the results. It's all about collaboration between human ingenuity and AI's analytical power.
So it's not about AI replacing scientists, but about augmenting our abilities and helping us see the world in new ways.
Precisely. Imagine a future where AI helps us to connect seemingly disparate ideas, to unlock creative potential we never knew we had, and to accelerate the pace of scientific discovery. That's the promise of this research.
Well, that's an inspiring note to end on. A huge thank you to Dr. Cameron Jones for bringing this fascinating research to our attention.
And to all of you for joining us in this mind-expanding journey through the world of AI and bio-inspired materials.
If you enjoyed this episode of Science Exposed, be sure to like, share, and subscribe for more deep dives into the world of cutting-edge science. And don't forget to check out the show notes for more ways to connect and keep the conversation going. Until next time.